Have you ever thought about all the different AIs out there from all these different companies trained on different data? What if they all secretly speak the same language? Well, a groundbreaking paper is saying they actually do, and researchers have just figured out how to translate it. So the big question is, how'd they crack the code, and what did they find hiding inside? So it really boils down to this one question. Are all these different AI minds actually heading towards the same single universal way of understanding our world? It sounds like something straight out of a sci-fi movie, right? But the evidence is starting to point to a pretty clear yes. And believe me, the implications are staggering. Okay, so to really get this, we first have to understand the problem they were trying to solve. You can pretty much think of the AI world as a digital Tower of Babel. Every single major AI model, from Google, OpenAI, you name it, it develops its own internal, totally secret language to make sense of all the information it processes. And what's really fascinating is how they do this. See, when an AI reads a sentence, it's not seeing words like we do. It creates this thing called a text embedding. The best way to think about it is like a unique mathematical fingerprint. It's just a long string of numbers, but it captures the exact meaning and context of the text. But okay, here's the catch. If you give two different models the exact same phrase, say hello world, they'll spit out two totally different fingerprints. I mean, they're both correct in their own way, but they are fundamentally incompatible. You just can't compare them. And that's made it basically impossible for these powerful models to work together. It's like there was no Rosetta Stone to translate between them. Until now, that is. So how did the researchers crack this nut? Well, they started with this really tantalizing clue, a hypothesis, really. It suggested that maybe, just maybe, underneath all these different AI languages, there was a shared, universal structure, a kind of hidden geometry. Yeah, it's got a fancy name, the strong Platonic representation hypothesis. I know, it's a mouthful, but the core idea is actually pretty simple. That phrase you see, universal latent space, just think of it like a hidden map of meaning. A map that all AIs, if they're trained on similar stuff, will end up discovering all on their own. It's like they all build their own roads, but every single road leads to the exact same hidden city. And that hidden city, that's the key. The researchers built a tool specifically to navigate it. It's a kind of universal translator for these AI fingerprints, and they call it Vec2Vec. Now, the really crucial part is this. Vec2Vec is the first ever method that can translate between these AI embedding spaces without needing any shared data. I mean, just think about what that means. Models could actually work together. You could transfer knowledge from a huge model down to a smaller one super efficiently. It doesn't need a dictionary. All it needs is a big pile of embeddings from each AI. They don't even have to match up, and it can figure out the translation rules all by itself. So, how does this magic trick work? It's basically a three-step process. First, it takes a fingerprint from model A and encodes it. Basically, it finds its location on that universal map of meaning we talked about. Then, step 2, it finds the corresponding point on that same map. And finally, step 3, it decodes that point into model B's language. It's kind of like translating from English to French by first finding the pure idea of something in a universal language that sits right in the middle. And the results? Honestly, they're astonishing. This isn't just some abstract theory. You can literally see it working, just slicing right through the noise of all those incompatible languages. Okay, so picture this. Before Vec2Vec, you tried to map out all the fingerprints from two different models. Even for the exact same set of documents, you just get two totally separate, jumbled clouds of data points. No connection, no pattern, just chaos. But then you apply Vec2Vec, and something incredible happens. This is what really shows the discovery in action. The two clouds just snap together. The points that represent the same documents, the ones that were lost in their own separate worlds before, now they overlap almost perfectly. The hidden structure is finally revealed. So just how perfect is this alignment? Well, researchers have a way to measure this. A score of 1.0 would be a totally flawless match. In Vec2Vec, it hits a score as high as 0.92. That is an incredibly tight alignment. It's solid proof that this universal structure is the real deal. And check this out. To really put it to the test, the researchers took a fingerprint from one model and asked another model to find its identical twin out of a lineup of over 8,000 possibilities. Now, just guessing randomly, you'd find it somewhere around try number 4,000. But Vectivec, on average, it finds the perfect match within the top 3 guesses. It's not just translating vaguely, it's pinpointing the exact meaning with absolutely stunning accuracy. Okay, but here's where the story takes a turn. This powerful new key, it doesn't just unlock understanding. It also unlocks a massive, previously hidden security vulnerability. Yeah, this universal translator has a pretty serious dark side. Let's circle back to that fingerprint analogy for a second. The old thinking was that even if a hacker managed to steal a whole database of these embeddings, they were basically useless, right? They're just anonymous strings of numbers. Without the original AI that made them, they don't mean anything. But what happens now? The attack is, well, it's terrifyingly simple. Step 1, an attacker gets their hands on a database of these anonymous embeddings. Step 2, they use Vectivec to translate those mysterious fingerprints into a format they can understand, like the language of a public AI model. And then, for the final step, they use other tools that already exist to reverse engineer that translated fingerprint right back into the original sensitive text. And this is not a hypothetical. The researchers actually tested this. They used a public dataset of old Enron emails, and from an anonymous embedding, just a string of numbers, they were able to recover the main topic of an email about Enron bashing. From another one, they pulled out financial details and even a first name, John G. All of a sudden, that data that was supposed to be anonymous? Yeah, not so much. And the scope of this is just huge. We're talking about company names, individual names, financial info, even stuff that's incredibly sensitive. The researchers showed that this same attack works on medical records. It makes it possible to figure out disease descriptions from what everyone thought were anonymous patient data embeddings. So this all leaves us with a really provocative thought, doesn't it? We've just discovered this universal language that connects the minds of all these AIs, revealing this deep, shared structure of knowledge. But at the same time, it proves that something we all thought was secure just isn't. It really makes you wonder what other fundamental secrets about AI are still out there, hiding in plain sight.